we're looking at domain and range, and our first question is, for this function here, we have a domain that's restricted to 2 or more. So this means you can only pick numbers starting at 2 and then like 2, 2.1, 3, that sort of thing, okay? So what would the range of this be? Well, the range refers to the y values that you can get, and it sometimes depends on the domain, the x values you're allowed to put in. So the best way to kind of answer these questions normally is to think about the function that you have. So x squared. So x squared, what does x squared look like? Well, we don't know where exactly yet, but x squared is often going to have some sort of minimum point in a case of positive x squared, and it would be above that. So for example, if, and I don't know this yet, okay, but if this were 1, for example, I could say that it is greater than 1, but it can also be value 1 as well, okay? So that's what we're looking for. Now, we can do a bit better than that. We can use differentiation, or we can use completing the square to find out where it turns. So if I complete the square, it just so happens I fluked the answer because I actually didn't know that before. So what this is saying is, if you remember the opposite sign here and reading this as it is, 2, 1 will be the minimum point on this curve. So if I draw this again, 2, 1 might be, say, there somewhere. It turns out that it's going to go through 5 as well, isn't it? So it turns out that this curve is a positive quadratic, something like that. Okay, so for my function, what I'm going to do, for my function, I'm going to say that the domain and the range, and you're going to see why I'm doing this in just a second. So the domain was given to me, and the range, which kind of results, so we're only allowed values bigger than 2. It's this part here. In fact, this part to the left doesn't actually exist in this question because it said you're only allowed 2 or more. Okay, so you could, if you wanted to, even kind of draw it like this. Okay. The range was, so we can write it like this, or we could have also written it like that. That's fine as well. So, what are we going to do next? Show that it's 1 to 1. So 1 to 1 means there's only one x value mapping to one y value. So you can see, because of the sketch here, that a y value only comes from one place, and an x value only leads to one place. So this is a 1 to 1 function. You know, a straight line would be a 1 to 1 function as well. Before, it was not a 1 to 1 function. And the reason for that is there were multiple values that would give the same y value. So that one there, for example, is called many to 1. Yeah, there's multiple inputs that lead you to the same output. So how could we give a explanation to this? Well, you know, you can clearly see it, but one way you might want to do it to kind of finish it off is if you said, well, if you differentiated it, for example, you would get 2x minus 4. And because you're only allowed values that are bigger than 2, when x is greater than or equal to 2, you can clearly see from above it's always going to have a positive gradient. So there'll be no way then for it to start going down. So this is one way that you could support the idea that it'll be 1 to 1. But of course, you know, you can just see that from the diagram. So how about the inverse function? Let's go for this one. Let's go over here. So we said x squared minus, in fact, let's put I'm going to start by calling it y equals x squared minus 4x plus 5. So there's a lot of ways you can do this. Minus 4x plus 5. I like to swap the x's and y's at the start. So x equals y squared minus 4y plus 5. Okay, and then what do I need to do here? Well, effectively, I'm going to need to get it so that it says y equals. So lots of ways I could do it, but let's try something like this. So x minus 5 equals y squared minus 4y. This will then be y minus 2 squared minus 4 equals x minus y. And if I start moving things around, I will get x minus 1 equals y minus 2 squared. The root, so the root, I'm only going to take the positive root here, and I'll show you why in just a second. So x minus 1 equals y minus 2. The final answer is going to be y equals root of x minus 1 plus 2. Now, why have I only taken the positive? Well, you might remember from inverse functions, it's often useful for us to sketch y equals x and reflect in this. And if I do that, well, what would the shape look like? It would look sort of something like this. Now, clearly, this only takes positive values. It can't take negative values. So that's why when I did my root here, I only had the positive case. Because I had already restricted my diagram to just this orange line, I only had the positive root. That's why I didn't have the negative root. That's why I didn't draw something like this, if you will. Okay, so let's try and understand this now. So what's the function and what's the domain and range of this function? So a nice trick that you can do here is you can find that you should just be able to swap these. So let me show you what I mean. So this one should just be x has to be greater than or equal to 1. And you can see this here. If you look underneath, if I have a number that is smaller than 1, I'm not going to be that square root. Able to do that. So there's going to be a problem, isn't there? How about the range? So the range should also just be about 2. And it should say that you are allowed values then of 2 or more. So if I put 1 in, I would get my smallest value, which would be a 2. So that's why it works. It also says I should be able to get values bigger than a 2. Well, if you look at my sketch, okay, this will just go on forever, in fact. But clearly it's going up from 2. So this box here works very, very nicely for domain and range. Once you get your initial ideas, you sort of crisscross them to get the next one. So let's show you that one more time, that crisscrossing idea. So state the domain and range. Well, the domain of G is all real numbers. That's given here. But let's just write it. So g of x, we'll leave some room for the inverse in a minute. The domain, the range. So the domain was all real numbers. Well, we could, if we really wanted to, we could just do that one over here now, if you remember what we said on the previous slide. And let's do that, and you're going to see that in just a moment that actually works. Range, what's the range? Well, I need to look at this and I need to understand what kind of graph I have in front of me. So this is essentially an e to the x graph, okay? The minus 3 is just going to move it to the right, the minus 3 inside the function, and the 2 at the front is just going to stretch the diagram. But ultimately, it will look something like this still. So if I'm allowed any value, left and right, well, what values will I have? So the answer to that is I would always have positive values. So I'm going to call this, I could call it y or f of x. And there's also an asymptote. I can't actually get the value of 0, but I can get very close to it. So again, we're going to do this for later. That should mean then that for this one, it should say x is greater than 0. And you're going to see this in just a moment. So let's find g of minus 1. So y equals 2e to the x minus 3. Y over 2 equals e to the x minus 3. The natural log, I haven't swapped I'll swap the x's and the y's at the end. I'll do it slightly differently this time. So the natural log of y over 2 equals x minus 3. X equals the natural log of y over 2 plus 3. And let's sort of exchange these now. So the inverse function is the natural log of x over 2 plus 3. Okay, So let's try and understand this one now. So if I look inside here, I would have an issue if I tried the natural log of 0, you might remember. So that sort of shows me that I've got the right idea here. Because I only want the natural log of numbers that are just above 0 and going up. So x is greater than 0. How about the y values that you should be able to make? It says you should be able to make any y value. So that's a bit harder to understand. But if I draw a natural log graph, they look something like this. So in other words, you can have any negative values and you can have any positive y values. And this line here actually never stops going up. It just goes up very, very slowly. So that's another example then where using the box has sort of shown me what the domain and range is, even in situations like this where it's a little bit harder to know that straight away.